In activity 2b, we're looking at vocabulary of lines, equations. We're asked to find the slope, the y-intercept, and the x-intercept, and to match the graph based on just the equation in slope-intercept form. Now that's going to be the key here, is that everything that we're looking at here is in the same form, every single equation. So the equation that we're really concerned with is the equation y equals mx plus b. So y equals mx plus b. This m right here represents our slope. That's the rate of change of y compared to the rate of change of x. And this value right here, so this is the number part without the x, just that actual number part, that's our y-intercept. Right, not the x-intercept, but the y-intercept. So I'm looking at number 1. We got the equation y equals negative 3/4 x minus 3. We're asked to find the slope, which is m. So again, that's the number that's floating in front of x. There it is. That's our slope. We're asked to find the y-intercept, so that's the other number that does not have a variable attached with it, and that's negative 3. Now the challenging part, I think, on these problems is how do you find the x-intercept? Well, we know that when the graph crosses the x-axis, the y-coordinate is 0. So using this equation, we set up 0 equals negative 3/4 x minus 3. Y became 0. Then we solve this using reversing operations like we did before. So we're going to add 3 to both sides to get that 3 over, and then get rid of the negative 3/4. And the way that we're going to reverse that is to either divide by negative 3/4, because it's 3/4 times x, or if you're dealing with fractions, really you don't divide fractions, you can multiply by the reciprocal. So if I multiply this side, I'd have to multiply by negative 4/3. And I do the same thing on the other side. And end up getting x equals negative 4. That's my x-intercept. Now to match the graph, essentially what I did is I looked at the intercepts. I looked at a negative 3 and a negative 4, negative 3 on the y, negative 3 on the x, and notice that h was the one that matched up with that. You could also use your slope to calculate that as well. On number 2, we're looking at our slope here, which is the number in front of x. It's negative 3. There we go. Looking at our y-intercept, which is my other number. There it is. And to find the x-intercept, once again, y is 0, so set 0 equal to negative 3x minus 1, and then solve from there. So I add 1 to both sides, and then divide by negative 3, and I get negative 1/3. Number 3 is a little bit tricky because there's something that appears to be missing. So again, I'm looking at the equation y equals 2x, so there's my slope, but then there's nothing after that. You might be thinking, well, that means that there is no y-intercept, but there actually is. Because after, at the end here, I can actually write this as 2x plus 0. It doesn't change the meaning of the equation, but it makes it in the right form, y equals mx plus b. So then 0 is that other piece to it, and that's my y-intercept. To find the x-intercept, again, I'm just going to plug 0 into here, and I'll have 0 equals 2 times x. So dividing by 2, x has to be 0. All right, now on to the next graph, or next equations. We have equation number 4, which is kind of a tricky one as well. So in this case, I don't have any x's. I'm going to rewrite this as y equals 0x plus 2. And here, hopefully, it becomes apparent that the number in front of x is 0. So that's my slope. And here, I've got my y-intercept. Now here's the cool part. Again, if we have the x-intercept, we know that y is equal to 0, and I set that equal, so I'm going to take my original equation here, and I'm going to have 0 equals 2. That never happens. So there is no x-intercept, because 0 can never equal 2. There's no solution to that equation. On to number 5, we have the similar idea here of x in front, or the 3/5 in front of x, and then a plus 0, just like we had on question number 3. So that means our intercept here is 0. And I can do the same thing for the x-intercept. Divide by negative 3/5. And truth be told, it really doesn't matter. If I take 0 divided by anything, I'm going to get 0. All right, let's skip ahead to a couple more challenging ones. I want to take a look at number 10 because I think this one's kind of a tricky one for us. So on number 10, we have a line x equals 2. This is not at all in the form y equals mx plus b. But what it's telling me is that x is always negative 2. It doesn't matter what y is. So if that's the case, if x is always negative 2, that means that it's never going to cross the y-axis. What I have is a vertical line, a line that's going to go straight up and down. So it might look something like this. So there's our coordinate plane, and then here's our graph of the equation, x equals negative 2. If that's the case, then my slope here is undefined. It rises a ton, but it doesn't run, if you want to think of it in terms of that. The vertical change could be anything, but the horizontal change is 0. We can't divide by 0. We've got an undefined slope. Now from this graph, then, we can tell that it will not cross the y-axis, so there is no y-intercept. And the x-intercept is what x equals. X equals negative 2. And again, looking at the graph, we can figure out that it's that graph I is the only one that's got that vertical line. And so that's what section 2b was all about. It's about taking that equation y equals mx plus b form, picking out the slope, picking out the y-intercept, and rearranging a little bit like we did here on number 11 to find out what x is when y is equal to 0. And that will find our x-intercept.